Whilst what you might see is written on the heading seems pretty pedestrian, there's not much to it. In a sense, that is correct. But in another sense, welcome, in another sense, actually there's some really cool and important stuff in here that you should not, so what's the phrase I'm looking for? You treat this as simple and routine at your own risk. There's actually a really important concept underneath here, which we'll dive into shortly. So why don't we, like the best way to understand what this is all about is just by having a look at an example question. You know by now that if you have been given some derivative function, f dash x equals this, then we know you got that derivative function by differentiating. So if we wanted to return to our original function, by the way, not the derivative, what's it called when we're going back? The primitive, because like from back in those days, you want to find the primitive, then of course the method that we use is integration. No big deal, right? But the question, as stated, we know that what we would get out of it, out of that process of integration, is not just any integral. What kind of integral would we get out of this question? An indefinite integral, thank you very much. Because at the moment you integrate. In fact, let's go ahead and do exactly that. If we were to want to get f of x, the way we would do it is by saying, well, let's integrate f dash, right? Because I have no boundaries here, right? There's not finding an area or something like that. You've been doing trapezoidal rule recently. There's no boundaries, so this is definitely indefinite. Definitely indefinite. This is certainly indefinite, which means we're going to get this constant integration flying out the end. Why don't we go ahead and do that? This is not a complicated thing to integrate. I've got 4x minus 1 with respect to x. So go ahead, help me out. What do I get? 2x squared, because I raised that index, I divided by that index. 4 goes into 2, and then? Wonderful, okay. So there's my indefinite integral, no problems. But sometimes we are given enough information, or we want to actually not just say, it's some family of functions. We call this the linearity of integration. This could be 2x squared minus x plus 1 plus 100 plus whatever you want, minus whatever you want. And they're all kind of on a line, linearity. We can actually, if we're provided more information, which I'm about to give you, we can be a little more specific. We can evaluate this constant that we have here. Now, the particular example value, or rather the example information, that I was going to provide you was, suppose we have some additional function value for the primitive, some known place that the primitive passes through, okay? Now, a common thing that you will get given is f of 0. If you substitute in x equals 0, you'll get some number, right? Because x equals 0, or t for time equals 0, or p for population equals 0, because that's such a common thing to receive, and because 0 is 0, you often get called, this often gets called the initial condition, okay? Because like, oh, at the start of this, where do we begin? But it doesn't have to be initial, and I'm going to give you a different one, in fact. I'm going to say f of 1 equals 3. So I'm told the derivative, and I'm also told this one specific spot that the function goes through. Now, I can't be plus 1, plus 100, whatever. I have to be at somewhere specific, right? And we're going to find where that specific spot is. So, if you're following along, step 1 was we did the indefinite integral. But now I can go further, because if this is truly f of x, I can say but, and please, like, emphasize what's going on here. Help me follow. Communicate to me clearly your flow of logic. But I know that f of 1, now that I've provided to you, is not just equal to anything, it's equal to 3, right? So therefore, this line here, I can actually just go straight into this line up here. According to what I have integrated, I can say, therefore, f of 1 would be, don't skip anything here, 2 of 1 squared, help me out, finish it off, minus 1, because I'm substituting in x equals 1, yes? Plus c, still don't know what that is. What's that equal to? 3, that's what I have on my right-hand side. So far, so good. And at this point, this is fairly routine. I want to know what c, the constant of integration, is. I just have to do a bit of tidying up. It looks to me like I've got 2 take away 1 plus c equals 3. That's a 1 on the left-hand side, a plus 1. So what am I going to do to both sides? I'm just going to minus 1 from both sides, which leaves me with this. we have successfully evaluated the constant of integration. But of course, as usual, when you get to the end of like, oh, I simplified some stuff, am I done yet? Am I done yet? No. Just one last line. What does the question actually ask? Yeah, I actually want the primitive, and this is just part of it. So all I need to do is just tie this up in a neat bow. I will say, therefore, f of x equals, and I'm going to substitute c, where it belongs. 2x squared minus x plus 2. Full stop. Happy? Any questions before I go on? Okay, wonderful. So let's just make sure we knew what was going on there. There's basically 3 turns that we take, right? What would you call this? This is the actual integrate, right? After you've done this, sort of calculus just steps out of the way, right? So this is the integrate step. What did we do? I would call it, I guess, here. What would you call that?
Find the constant.
Yeah, find the constant, or maybe because this is what we were doing, finding the value of something, got a word for that. I'm going to call that evaluate, okay? And then just, I mean, it hardly warrants being called a step, but you do, like this is a distinct thing. I guess I would call that like you're substituting, right? You're taking that thing which you found the value of, see, and you pop it where it belongs. Happy times, okay? Now, what I'm going to say is 99% of you, for 99% of questions, will do exactly this. It might not be a polynomial that you have. It might be, you've learnt how to do, right? What kinds of functions can you do aside from polynomials? Exponentials, what else? Trigonometric functions, what else?
No.
Well, we won't differentiate the logs themselves, but we can we can result in a log if you have something like, I don't know, 3 on 3x minus 1. That'll turn into a log, won't it? By the way, what was the thing, a lot of you are nodding, what was the pattern that you could see here that told you this was going into a log? What do you see? Very good. It's not just any fraction, we call them rational functions. Not just any fraction becomes a log, it's of that particular form whereby it's f dash on f, and you're like, oh, sweet, I've got reference sheet, this reminds me, okay? So we can integrate all these things. You're going to see examples of those in the assigned questions.